Hey guys, it's Mrs. Morgan, and we're going to review factoring. X squared plus bx plus c, a squared plus bx plus c, and differences of squares like a squared minus b squared. We're going to factor each polynomial. So our first problem, x squared plus 17x plus 42. We are going to look for things that multiply to 42 and add to 17. You can make a t-table and just work your way down. Start with 1 and 42, no good. 2 and 21, no good. 3 and 14, aha. So we're going to use positive 3 and positive 14. So we'll have x plus 3 and x plus 14. And that's what our answer will be for that. And our next example, and I'm going to show you, this is going to look a little bit different. We're going to factor each polynomial. We have an ax squared plus bx plus c. And the first thing that we're going to do when we look at this is, again, we're going to find things that multiply, but we're going to do 4 times 10, which we're going to look for things that multiply to 40, and they need to add to 22. And actually, before we do that, there's something else that we need to do first to make this a bit easier. When I look at 4x squared plus 22x plus 10, there's a greatest common factor. I can take a 2 out of everything. That's going to make my life a bit easier. So we're actually going to start with that. 2x squared plus 11x plus 5. Okay, and we'll just need to remember this 2 at the end. We'll tack that on to our answer. So instead, we're going to be multiplying to 2 times 5, which is 10, and we're going to add to 11, which when I think about things that multiply to 10 and add to 11, I'm going to say 1 and 10, actually. And I'm going to rewrite this 2x squared, and I'm going to say plus 1x plus 10x, because my 1 and my 10x, my 1x and my 10x still go back to my 11x plus 5. Now when I look at these, 2x squared plus 1x, I can factor out an x from both of those, and that's going to leave me with 2x plus 1. And then I'm going to look at my 10x plus 5, and out of both of those I can plot a positive 5, and that'll leave me with 2x plus 1. And looking at this, I see that these two things are the same. So the first part of my answer, I can do 2x plus 1 in parentheses, and then I'm going to take my pieces that are left over, my x and my plus 5, and I'm going to have x plus 5 be my second piece. And then again, from before, it's very important, since we pulled out this positive 2, we need to bring that down and put that on the outside of our final factored answer here. Now I know this is a bit different from the boxes, and if the boxes work for you, when I say the boxes I mean this thing, if that still works for you, that is totally fine, but I know that I've been kind of having you take a different approach in class. So I will kind of leave that up to you for now. All right, in our next example, we want something that multiplies to 20 and adds to 3, which we've got 1 and 20, 2 and 10, 4 and 5, 5 and 4, None of these are getting me that 3, so this is prime. We cannot factor it anymore. Okay, last we're going to look at some difference of squares, and q squared minus 121, we're subtracting, and this is a perfect square and this is a perfect square. So our square root of q squared is just q. Our square root of 121 is 11. And so what we're going to do with this is we'll have q plus 11 and q minus 11. And when I look at example 5, the first thing that I should notice is that I've got a greatest common factor that I can take out of both of these, so we're going to factor out that 2. So then we have 2 times c squared minus 16d squared. And right away that should look a bit better because this, well, it looks more square rooty, if you will. So our square root of c squared is just that c. Our square root of 16d squared is just the square root of 16 and the square root of d squared, so 4d. So we'll come over and c plus 4d and c minus 4d. And also, since we factored out that 2, we need to remember to bring that across and tuck that right on the end there. All right, that's a quick review. Let me know if you have any questions.